This screencast is to explain the share folio that we've got and run through a couple of things that you'll need to know in relation to producing a folio. Every time you get one of these tasks, there'll be a cover sheet to it that explains the description of the assessment, the purpose of it, and then the assessment design criteria, and then of course a rubric that shows you what you'll be marked against. If you are going to be operating in this area, the maths that we need to be seeing need to be shown to be appropriately selected, have some complex algorithms, which basically means complex processes to solving things, to solving complex questions. So it can't just be the routine maths like buying shares, selling shares. It might have things to do with dividend imputation and taxation and the discount rule and those kind of things. It also wants you to look at a highly effective and accurate application. So you're trying not to waffle around too much with the maths that you're trying to do, but show concisely what you're trying to solve. And also you have to be able to demonstrate a comprehensive knowledge and understanding of the concepts and the relationships. And that may come through writing stuff as well, not just the maths. If you want to look at the next bit, which is the mathematical modelling and problem solving, you need to have effective applications of mathematical models. So it's just exploring how you solve the problem effectively using models that have some complexity to it. The solutions you need to be doing need to be complete and concise, which means that you don't waffle around again to try to come up with a solution. There's no point showing the reader how to buy shares 75 times, because if you've done it once, we know that you can do it every single time. So you need to think about the mathematics that you're using. It also asks you to have an interpretation, the concise interpretation of the mathematics. Now this is the thing where most people kind of fall over a bit, because what you're trying to do is you're trying to solve a problem and have a concise, succinct answer of the solution to the problem. If you waffle on, then you're actually not hitting this concise bit, so you've got to be careful that you don't make this bigger than Ben-Hur in terms of the writing that you've got there. The other thing is this reasonableness and possible limitations in the results. So you need to know the assumptions that you're doing, the reasonableness and the limitations of what you're trying to explore. So things like in the share project, you might be going back in time to buy shares. Now, an assumption is that you can do that, which is you can't do it. But the limitations of it are, in real life, you haven't got that ability to go back and buy shares in hindsight. You can only buy shares on the data that you have at that time. So that's the limitation, and it's going to have an effect on how you solve the problem or the task that you've been given. So you need to be very wary of that. So these things here are actually quite tricky to do. And the last thing over here is communication. So it's got to be effective communication and reasoning behind the mathematical ideas. So you've got to be able to explain what's going on and why they work that way. So if you have a moving average, you want to explain how that moving average works, what that shows you, and why that is a good indicator to use. Once again, being concise, not waffling. It's a bit tricky to do. Yeah, the task then is Sid, as in Sid and Manfred, was thinking about the share market and said to Manfred, it's easy to predict the market and to make money. Manfred said that's why no one pays attention to sloths. Who is right? So Sid is saying that it's easy to make money on the market if you pay attention to what's going on, and I can make predictions, whereas Manfred's saying there's no way it's going to happen. Who is right? So the two things we're looking at is it possible to devise a method that will maximize your returns, and is it possible to predict trends in the market? So these two things here are the things that you need to be focusing on for this project. And you can see that it is quite open-ended. There's no real right or wrong answer to it, but you need to kind of work through a process to show the reader that you found out a bit of a solution. In the task, you can use your skills from Maths Apps to demonstrate if you can or if you can't devise a plan or a method that will be able to help you make money. So a couple of facts that you need to have in the back of your head here is one, you can spend about $40,000. You've got about $40,000 up your sleeve, okay? You can buy or sell as many times as you want, but limit yourself to a 10-year time frame. You can grab shares and share prices that go back a long period of time, but anything more than 10 years back, you might just be kind of, I don't know if the mathematics is going to be there strong enough to be able to show what you're trying to show. And all your calculations, please use a marginal tax rate of 42%, okay? In your introduction, you're going to have to carefully say what you're trying to find. And this is one of the tricky bits. So let's have a bit of a think about how you could solve this. So first thing you could do, you could just, as an absolute minimum, you could buy some shares and then sell them over a variety of time frames. So you might just want to buy some shares, sell them. You might buy them for 10 years, you might buy them for 5 years, you might buy them for 3 months, and then compare your returns. Use the same shares, use the same volumes, and see what happens. And then that would be the absolute minimum. So just buying them, selling them of a variety of time frames. Okay, that's the first one. In doing that though, you will have to work out any capital gain or loss. You'll have to work out any tax payable, and then you also have to talk about market trends. So this is the absolute minimum. Okay, if you want to take it any further, that's when you'll be looking at some of the more complex mathematics. There's some other things you can look at. You can use moving averages to see if you can maximize your profit. You might just want to buy and sell some shares to start with, regardless of the date, and then make up a moving average and buy and sell using the moving average as your trigger and compare to see if you make any more money. That could be an interesting thing. You might also want to make up your own indices, like a share market index. You might want to compare yours to the All Ordinaries Index. Then you might be able to use that as a prediction of when to buy and sell. So you might come up with your own index, Fred's index for instance, and that might be similar to the All Ordinaries Index, and you can then compare that and see by using your index number as a judge of when to buy and sell of when you can actually make more money. The other things you might want to be interested in looking at too is that, do the shares that you have pay dividends? If they do, what's the dividend imputation on that? How does that help you? Is that advantageous for a shareholder to have in the back of their pocket, or is it better not to worry about dividends at all? So that's another good discussion to have. You might also want to talk about inflation and the effect that has on your investment, and does the yield, what does that show you, and does it help you make any good decisions? And are there any other investment strategies that you found in your research? So this kind of thing here is you're going to have to think carefully about what these things show, and you may actually have to do some research to see what you can use these things for to be able to predict. Because remembering, you're trying to prove whether you can predict to make more money than if you just buy and sell. That's basically what we're looking for. So it's quite a complex little thing. It's important to do, if you're going to do the more complex stuff, to make sure you get the minimum possibilities, which is buying and selling, nail that first. Do that properly, do that clearly before you go to do anything more complex. Otherwise, you'll shoot yourself in the foot with a big mess. Okay? Right. The next bit is really important. This is what you need to submit. Okay, this is what you need to hand up at the end. And some people kind of jump into the maths without thinking about this. So have a look at this. The first thing you need to do is an introduction. The introduction spells out for you what the project is about. It has to be detailed, not too long, but it's got to be able to explain what's going on. So you would have to be able to explain the situation. I'm trying to find out whether you can make money on the share market, and can you maximize your gains and hence be able to predict what's going on so you always end out in front. Then you're going to have to talk a little bit about how you think you're going to solve this and what you'll find. Okay, so I'm going to use a number of strategies. I'll be doing this, 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 and this to come up with my solution. The method of the solution is often evident in your mathematics, but you might want to briefly explain that. There's no point telling me, now I'm buying some shares, now I'm selling some shares. I buy shares by doing the consideration, brokerage, GST. No, you don't want to do that because that's evident in the mathematics. The mathematical model of strategy is what you're using to try to find it, and in doing that, you need to interpret your results. You need to talk about the assumptions and limitations, and at the end, you want to have a statement of the solution. Okay, so you want to show the reader what you have found. Alrighty. Now, in terms of what you actually have to hand up, you've got to have an introduction, got to have some mathematical investigations, analysis and discussion, and a conclusion. When you read the next things down there, it kind of shows you what needs to be in there. So what actually has to be in it? If you're going to say, Rodio, what do I have to look for? What do I have to put here? These things here, these 6 things are really important. Okay, you need to have a title page. You need to have a contents page. People forget this and then they get shot in the foot because they haven't done the bit on communication. Okay, it's only a little thing, but it's part of what we look for when we mark this. It needs to have an introduction, calculations, analysis, and a conclusion. So, Remembering, if you have a look at the next bit down here, give an overview of the problem being investigated. Remember, this is you're describing the problem that you'll solve, and cover what's in the question sheet. Summarize how you're going to present your findings and outline possible solutions if they can be predicted, but be careful of actually giving us the answer to the question before you actually go through it and solve it. Okay, if you have any calculations, they've got to be really clearly labelled. If you have charts, make sure you have proper axes on them. If you have tables, explain what's in the tables. And if you have got spreadsheets, you can put them in there. You can actually put a spreadsheet inside a document as well, or you can cut and paste it or do a screenshot and put that in as well. And also, because this is sitting inside docs, you can drop anything that you have found inside a sheet or a drawing. You can drop it straight into this document and it will be there all the time. Write a short comment to summarize your calculations. This will support your marks for communication and analysis, so this is really important. Don't make it long and waffly, but this helps you do the communication bit. If you've got lengthy spreadsheets, which I don't know if you'll have, you can just include a link to them if you want, and then I can check them, or you just do the first couple of rows. And also, it's good to put the formulae of the spreadsheets, if you're going to do that, and throw them in the appendixes. Now, the appendices will be really helpful because you can put a lot of information there. It's not counted in a word count, but be careful not just kind of making it into like a phone book. And then down here, the analysis and interpretation, you can actually read this bit here, and it tells you what you should be talking about. And one of the important things here is to make sure that it's only 1.5 to 2 pages. Okay, there's a good thing you can do is you can actually start writing down all your findings in dot points and then explain them. Okay, the other thing which is really handy is a table that summarizes your results. So put all your results in a table and then you can just draw conclusions by looking at the numbers there. It's really easy rather than having your final conclusion full of words and numbers and all those kind of things. If you can put your numbers and your findings in a table and just refer to your table, that's really good. Okay, make sure that it flows really well. Read it very carefully. You can actually present it as this Google Doc, so use this doc to write in, and anything done in sheets you can put into the doc. Check for your clarity of expression. Use terminology that's appropriate to the maths here. You don't need to do this bit here. Presenting it stapled, you don't have to do that because this will just be submitted electronically and you don't have to worry about that at all. Anything that you need for supporting information, you can put in the appendices. Make sure you refer to them. And as I said before, this will be given to you. You'll be handing this in as an electronic thing. So this last bit here about page numbers is not really needed. And your bibliography, if you have a bibliography, make sure you do that correctly as well. But you can use the research tool in Google Docs. When you come down to the end of your task sheet, you'll find that what's happened is a title page has been added in there, so you can fill that in. The next page, if you scroll down a bit further, will come up with a table of contents, and away you go from there. So this document here will be in your Google Drive, and you can use it to do your project on. You do the project at the end of it. Okay, so it'll be named. I'll be able to give you comments as we go, but the reason for having it in the Google Drive is that then you won't lose it, and then when it comes to submit it, I can just grab it from you and it's there, and you don't have to worry about not saving your work, and it's always accessible for me to add comments. The good thing about having it in Google Drive is that I can pop in and out whenever you change something, leave you a couple of comments, you can have a look at it, and if that's a particularly boo, then you're really good.